Hi guys, today I'm going to give a presentation on the topic 5-minute rule 10 years later and other computer storage rules of thumb, which in the title itself indicates that with today's technology, 5 minutes is a good lifetime for randomly accessed pages and 1 minute is a good lifetime for 2 pass sequentially accessed pages, whereas 16 KB is a good size for index pages. These rules of thumb change in predictable ways as technology ratios changes. And these are the contents today we are going to discuss in our presentation. Firstly, coming to the basic concepts, 5-minute rule. This paper's central concept is a 5-minute rule. The guidelines state that it's preferable to retain data in main memory rather than disk storage if reading or writing it from storage takes less than 5 minutes. Data is kept in this hierarchy of storage at varying levels with varying costs of access and speed. Database management systems and disk IO. It goes into how the 5-minute rule has affected DBMS performance and architecture. Organizing and arranging data can help to maximize access patterns. For example, to reduce search times, we group together relevant data on disk. A general guidelines for indexing databases is the rule of thumb, which says that the tree index should fit in memory for effective access, is connected to database indexing. Next, coming to the problem definition, the problem of optimizing computer system data storage is particularly focused on figuring out how long to storage the data in memory before writing it to the task. The authors expertly illustrate the challenges associated with storage management in the context of evolving technology, highlighting the trade-offs between RAM and disk access costs. They also provide a clear explanation of the rationale for 1 minute and 5 minute standards. Next one is significance. In significance, the paper identified problem is important and per, pertinent. With the economic and technology evolving, the author focused mostly on storage management rule optimization. Coming to a few examples of practical applications, web servers, database, data warehouses are there. Coming to web servers, they have to store and retrieve large amounts of database, which administrators may lower storage costs and enhance query performance by optimizing data storage. The other one is data warehouse. Here, these are used to store and analyze large amounts of historical data. Data storage optimization has long been a problem, but it continues to be so due to the exponential growth in data generation. Next one is challenges. Here, the study does not state the computational complexity and the NP completeness of the problem explicitly. Data storage optimization problem has small search space, meaning that there are n possible solutions. Good solutions to problems can be found by utilizing effective algorithms. The issue of optimizing data storage is not that difficult to resolve. There are numerous algorithms available that can be handled practical inputs or problems. Sometimes the issue is difficult to resolve also. The upcoming one is assumptions and limitations. Coming to the assumptions and limitations, the work reviews and develops the 5-minute rule, which was the first proposed in 1987 study, because it provides an update on the new considerations of the original idea rather than the stupid variant. This research addresses changing the disk and RAM prices, changing the storage capacities, shifting technology ratios also, because it has updated the guidelines and added new metrics. It provides a more relevant basis for storage optimization. They cite several relevant papers in their work and analyze benefits and drawbacks of these earlier approaches. Over time, the price of RAM and disk space has not changed, but since RAM has become less expensive recently, this presumption isn't always accurate, during which time disk storage stayed the same price. RAM and disk storage costs will remain constant over time. The 5 minute and 1 minute rules of thumb will be much more accurate. Coming to the proposed approach, the topic of discussion in this study is an extension of earlier investigations, particularly in 1987 introduction of the 5 minute rule by Gray and Puzzolo. Criteria and addition of new measures, modification accounts for shifts in technology ratios, disk and RAM pricing and storage capacity. The 1 minute rule are two new general guidelines for data caching that the author suggested. The methodology's presumptions and limitations are also discussed by the authors. Instead, performance and financial arguments are used to inform storage decisions, which are then governed by guidelines and metrics. Coming to the methodology, evaluation of 5 minute and 1 minute rules has been concluded, involving a comparison of proposed approach with the previous method. The proposed approach demonstrates superior performance in specific areas. However, it is important to note that the approach leans towards a more historical nature. Consequently, the absence of formal arguments and experimental data may be considered a limitation. Finding a balance between the practicality of heuristic approaches and the need for formalization could be strengthen the overall approach, highlighting the specific scenarios or use cases where the proposed approach excels to provide context for potential users and researchers. Finally, conclusion and future work. Coming to the conclusion and future work, the 5 minute rule 10 years later and other computer storage rules of thumb implements implications for the system design are comprehensively explored here. The insightful work introduces several new rules that serves as guidance system designers on effectively managing and utilizing storage resources. The future work may include developing more accurate guidelines for coaching and other storage management techniques. Requires a careful examination of how state-of-the-art storage technologies such as SSDs and non-volatile memories. The goal of this endeavor is to keep up the latest developments in the storage technology. These are the references that I took from the paper. Thank you.